product. Now a little bit about the dot product. What exactly does the dot product do? The dot product represents the angle between any two vectors. Okay, it determines how much energy in a wave is present in another wave. So this is something that you're kind of seeing some applications here, and it's also used to take a signal and decompose it into sine waves. So that's what the dot product is used for. And so now what the dot product actually is this is how the dot product is represented. What you're going to do is you're going to take two vectors. All right? You're going to multiply those two components, and then you're going to add them together. There's also two other formulas for the dot product. Okay. And so I'll let you go ahead and get those down, and then we'll talk a little bit about how we can find the dot product. It is fairly easy. So. Okay, so do we have them all down? We ready to go? Okay, so let's look at an example. Find the dot product. So to find the dot product between these two vectors, what you're going to do is you're going to multiply the first terms, and then you're going to add that to the product of the second terms. So I'm going to take negative, oops, got to have a pen first. That would help. I'm going to take 4 times 2, and I'm going to add that to 5 times 3. So the dot product between these two vectors will be 23. Okay. All right, yes, that's it. So now, here you go.
So that's the angle?
That is the dot product. We will talk about the angle shortly. I know, and we will take care of that. So here you go. Find the dot product here, folks. Shouldn't take you that long. You should probably be able to maybe even do this in your head. Okay. Find the dot product.
I'm going. No.
So let's see what you got. Good job, we got 0. Okay, now how we got 0 is we took 2 times 1, which is 2, plus negative 1 times 2, which is negative 2. So we have 2 times 1 plus negative 1 times 2. When you do that, you end up getting 0. All right, oh, just a second, let's go back. Okay, we have another one right here. Here you go. Okay, I'll go ahead and get the voter out of maybe. There we go. Out of the way.
Negative sign on between. Where's the negative sign?
Left of the 7.
Oops. I knew the answer before. I just didn't know the answer. I think we both know that now.
And the answer is negative 6. Now where the negative 6 came from is 0 times 4 is 0, plus 3 times negative 2 is negative 6. So now, man, it's skipping today. Here is the angle between two non-zero vectors. So you were just asking how is it used to find the angle. This is how. So the cosine of theta, and this is actually taken from the dot product formula I had you write down on the second slide, except for we just solved now for cosine of theta. So you're going to see that it looks really familiar with what you wrote down earlier. So, cosine of theta equals u dot v, all divided by, what is this absolute value stuff? Magnitude of u and the magnitude of v. So let's go ahead and look at an example. Find the angle between u equals 4,3 and v equals 3,5. So what we're going to need to do here is we're going to need to find the dot product between u and v. We're going to need to find the magnitude of u and the magnitude of v. And that's all before we can even use the formula. So first of all, we have u dot v, the dot product. So u dot v will be 4 times 3 plus 3 times 5. So what does that come out to be? 27. So now what I need to do is find the magnitude of u. So to find the magnitude of u, remember that is the square root of 4 squared plus 3 squared. So that gives me a square root of 25, which gives me 5. And last but not least, the magnitude of v. Square root of 3 squared plus 5 squared. What will that be the square root of? 34. So I'll let you get that down, and then we'll continue with the formula for finding the angle between those two vectors. So how we find the angle, remember, cosine of theta equals u dot v on the top, so 27 on the top. On the bottom, I have 5 times root 34. So what you need to do on your calculator, if you're going to do this on your calculator, you need to make sure you put this in parentheses. So go ahead and take 27, divide it by 5 root 34. I need to know to 4 decimal places what you get.
I got 0.9261.
Somebody else get 0.9261? You just do
You
cosine.
just think you're so.
No, don't do cosine. I just want you to do, yes, you.
You just think you're cool.
So then now, once you do that, I need you to take the inverse cosine of that. Okay, so now what you're going to do is take the inverse cosine of both sides. 22.17. Did somebody else get 22.17?
I did.
Okay.
The 4 lost.
So, questions? So first of all, find the dot product. Find the magnitude of u, magnitude of v, and then take the cosine, or inverse cosine of that. So with that in mind, here you go. Okay? Find the angle between u equals 710, v equals 4, negative 4. And then when you get that answer, I want you to go ahead and enter that angle in. If you just want to round to the nearest tenth, that would be great. The first one.
Got it. First. I'm first.
First runner up.
If you please, right?
No, you cheated. You just typed in the wrong answer. It's funny to how you think you're right.
I thought you said you were done.
I am not that kind of. I looked real quick. I was kind of hurrying to get out of between. I will turn the
That's what I said.
so, nearest,
You're saying my
nearest 10.
you're saying my core is really tired.
You're watching Dragon Ball.
I was in core. I actually probably more. I actually 25.
You didn't.
You need to be core is your most important.
Feel bad.
No, no, it's
Okay,
because,
you saying bad?
yeah.
Okay, we've got, I'm gonna let you go
Just
first.
pieces.
A little bit more and we'll see how you.
About the same.
What you actually said? So you got 100.01. How'd you get? Yep. Make your take.
I got negative 12 over 42.
That's good.
Oh, sheesh.
I got 100 or 106.
Well, pretty close to what I got.
Well, yeah, I just had the bottom wrong bottom.
But I got it right. Yep. There you go. Speed
Speed
is
on,
better.
accurate speed on. Doesn't matter. You just type it in.
Yes.
That's all that matters.
You just type
You
in.
get it all wrong.
Yeah, next time I'm.
You're probably just sitting over there waiting for it.
Okay, so let's go ahead and see what everybody got.
Yeah, 100.01
Oh,
counts,
see,
right?
Ross, you got it wrong.
Okay, so
100.01.
those of you that had 100.01, you're right as well. That's why I said when I coded this, I didn't give any variation. And so actually then we would have about half of you that got this one right. A little bit about that. Okay, the biggest mistake that I think some of you made is you didn't use the negative. So if you got like negative 80 degrees or negative 79.9, you actually missed a negative sign and that's what threw you off. But the dot product, when you calculated that, you should have gotten negative 12, and that's the difference. Okay, and so then you had the magnitude and magnitude of V. So your answer actually came out to be 100.007 degrees. So anyway. So now what we're going to do is we're going to talk about what orthogonal means. Orthogonal also is referred to as perpendicular. So that's another fancy way to say that two things are perpendicular. We say that the two vectors are orthogonal. And so that is two vectors whose dot product is 0. So that's how you know by calculating algebraically that two vectors are perpendicular or they're orthogonal. Their dot product will be 0. And so I have a question here. With that in mind, I want you to go ahead and answer that for me. Are those two vectors that I have there orthogonal? I went ahead and sent it to your expressions, so you need to go ahead and answer yes or no. So are U and V orthogonal?
I just voted to guess. I'm gonna do this.
50-50. I mean, that's pretty good.
Are U and V orthogonal?
It is.
Yes
It's yes.
or no?
The chance is
And the answer is yes, right. Because their dot product, if you calculate their dot product here, you get 2 times 6, which is 12. If you add that to negative 3 times 4, you get negative 12. So in fact, the dot product is 0. So they are orthogonal. So you would know right away that those two vectors are perpendicular. So now the last thing we're going to talk about today, and that's the projection of U onto V. The projection of U onto V. Now notice how you write that. The projection of U onto V, so you put that little v, that's actually a subscript. That's not a number, not a full-size number. So V is actually a subscript. How we calculate that is we take the dot product of U and V, we divide it by the magnitude of V, quantity squared. That will be a number. So this is going to be a number. And then we're going to take that number times vector V. So our answer will be in component form. Remember, that's the one with the two, yep. Answer will be in component form. So when I mean that, it's like this, okay? V1 comma V2. So when we're finding projection here, we're not finding a number, it's actually a vector. So let's go ahead and look at one of those. Find the projection of U onto V. So the first thing I need to find is I need to find U dot V, and then I need to find the magnitude of V. So U dot V, and then I need to find the magnitude of V. And we'll talk a little bit about it being squared as well. So the dot product of U dot V, what's it going to be? 8. 3 times 6 plus negative 5 times 2. So that's 8. So now I need to find the magnitude of V quantity squared. Now this is the beauty of this problem. If you remember, magnitude is square root, right? So if you square it, you get rid of the square root. So all I'm going to have to do to find the magnitude of V is I'm just going to take 6 squared plus 2 squared. Because when you square it, the square root cancels. So 6 squared plus 2 squared is 40. So now I have the projection of U onto V will be as follows. I'm going to have 8 over, what, 40. And then what I'm going to do is I'm going to take that times vector V, which is 6, 2. So I've got 8 over 40 times vector 6, 2. 8 over 40 I know is 1/5. So can somebody tell me what my answer is going to be? 6/5 and 2/5. Yep, this is a vector, and that's your answer. Pretty straightforward. All right, I would be expecting a quiz soon. Here is your assignment. This will be due tomorrow. Okay. I'm going to check your other one right now. So, anyway.